Welcome. In this video we are going to use implicit differentiation to find this derivative. That is the derivative of sine inverse of x. And here I've given you some information that you might or might not remember from either pre-calculus or trigonometry, that if y equals sine inverse x, then sine of y equals x. And we have to restrict the domain of sine y. That is, we have to restrict y in order for sine inverse of x here to be a function. Okay, so let's begin by finding the derivative with respect to x of sine y and the derivative with respect to x of x. So that is, I am just finding the derivative of this equation here. So on the left-hand side, the derivative of sine is cosine, and this is y. So remember, when we use implicit differentiation, we are assuming y is a function of x, and we don't know what function y is. So we are applying the chain rule here in essence by first taking the derivative of the outer function, which is cosine, the derivative of sine of the outer function is cosine, and leaving the inner function of y here intact. But then we do have to multiply by the derivative of y with respect to x, which is just dy over dx. And on the right-hand side, the derivative of x with respect to x is just 1. Rewriting, we have dy over dx equals 1 over cosine y. And now I need to rewrite this a little bit further, since I know that I started with sine inverse of x, so I want my derivative here to be with respect to x. And right now here it's with respect to y. And I really don't know what cosine is in terms of x right now. I'm just given what sine is in terms of x and y's here. That is, sine y here is equal to x, and I'm going to use that to figure out what cosine y is. So recall from either pre-calculus or trigonometry that cosine squared theta plus sine squared theta is equal to 1. This tells me that cosine theta is equal to the square root of 1 minus sine squared theta. And that's almost what we have here. If we replace this theta with y, we know that cosine of y is 1 minus sine squared y, all inside a square root. So dy dx is equal to 1 over the square root of 1 minus sine squared y. Well, what is sine y? We know from the problem statement here that sine y is equal to x. So this tells me that sine squared y is equal to x squared. So the derivative of the inverse function here of sine inverse of x is equal to 1 over the square root of 1 minus x squared. I hope this video has been helpful.